Oh yeah.
Ours is pretty dry.
Yeah. I think like sometimes my sisters make some, they use like contact solution or hot water and borax as an activator, and it's not so grainy, and then it makes it way more flexible.
Yeah, I can see it though because it's got the salt in it too.
So like savings.
Yeah. So basically savings. Oh yeah.
On our way to Ekmek with stuff on it gives me keep working at it.
It's getting better.
Yeah, the more you eat it, the more it'll like break down.
Yeah.
Borax.
I dropped mascara on my, I was running late, so I was doing my makeup in the car. And I just dropped my thing, I was like,
What do you present? Oh, are you presenting development? We don't have to present until Thursday.
Thank goodness.
I was praying that we were first.
Oh, you guys are first.
I went to Marie's.
I need to go to this one.
Like 4 different colors.
So do you have a gold one or a silver one?
Yeah, gold one, and then this one, I have a gray one, and
All right. Get ready? Yes, sir. All right, so today we're going to talk about reactions. So, the first type of reaction is a bond that we have an ionic bond, when a metal bonds to a non-metal, and there's unequal sharing of the electrons. So one of them just basically takes the electron away. So what you got here are your metals over here. Transition metals, we don't care about today. And then you have your non-metals on this side of the periodic table. So if a lithium bonded to a carbon, it would be an ionic bond. Covalent bonds now are a beast of their own. What happens when a non-metal bonds to a non-metal, so a carbon-carbon is a covalent bond, but that's also non-polar. Polarity is also comes into play with these. So carbon to carbon is non-polar because they share their electrons equally, whereas if you had a fluorine and a hydrogen bond, FH, it would be a very polar covalent bond. So what I mean by when they share electrons, it's the electronegativity. So electronegativity increases as you go across the periodic table to the right, and up. So what's the most electronegative element? It's fluorine. You don't care about the 8th column because they all have 8 electrons in the valence shell. Let's go through some examples real quick. Is the compound covalent or ionic? If it's covalent, is it polar or non-polar? It's a metal bonded to a non-metal, so it's ionic. So polar, non-polar doesn't really matter. Is the compound CO2 covalent or ionic? Is it covalent? Is it polar or non-polar? Yes, it's both. Endothermic and exothermic reaction. Endothermic absorbs heat and it feels cold to the touch. Because it's storing energy in the bonds. It's like ice melting, which is not a great example. Because the reason why ice is melting is endothermic is because it's cooling the surrounding area around it. And exothermic releases heat, gets warmer to the touch. That's because it's breaking bonds and releasing energy. Like hand warmers, explosions, stuff like that.
So we decided that what better way to have reactions than talk about Diet Coke and Mentos. So we chose this because it's a good reaction, it's fun. The reaction actually has 2 parts in it though. It has the breakdown of surface tension and then the increase in nucleation sets. So soda, as we know, has carbon dioxide mixed into it to create the carbonation. So that's that. All of the carbon dioxide is broken into it. And when the Mentos go into it, it breaks down some of the surface tension due to the ingredient gamma-radic. it reacts with the water and soda and breaks down those bonds a little bit to make it easier for the carbon dioxide to be released as gases. So this nucleation is actually a thing that already occurs in soda. So when you pour soda into a glass, you have the like cracks in your glass and such, and you'll see the bubbles start to form. So this is the process of nucleation as carbon dioxide starts forming gas. So after the breakdown of after the Mentos has made the surface tension get broken down, the Mentos are actually extremely bumpy on it. It's microscopic, but you can't see it with the human eye. But there's actually a lot of ridges and bumps included in those Mentos, and this is where the gaseous bubbles begin to form. So the massive increase in nucleation sites forms the gaseous bubbles, and then these bubbles have to go somewhere, which creates the explosion that we see when we drop the Mentos into the sun. The reason this works best with Diet Coke is because Diet Coke has the most carbonation and sweeteners that react the best with the Mentos gum, as opposed to other sodas.
Now we all know science is a little boring, so let's talk about something more fun, like the history behind this. So Coca-Cola was released in 1886, a pretty long time ago, and for nearly a century the brand did not extend or do anything at all besides just produce Coca-Cola. However, in the late 1900s, America and the world as a whole were starting to lean more towards the diet beverages. They wanted low-calorie, healthy sodas. Came up with the secret project, right? Very exclusive. You could not work on Diet Coke unless you first signed an agreement saying you wouldn't say anything about it. You also didn't get to know what the project was until you had fully agreed to it. And in 1982, Diet Coke was released for the very first time, and it was huge. Actually named Soda of the Year, believe it or not. Let's talk about some Mentos. Much less interesting story. 1932, Mentos were released in Poland by some brothers, and a couple years later they made a different flavor of the same candy. Now let's talk about the combination of the two. Alright, everybody likes some late night shows, huh? My favorite is probably Jimmy Fallon, good guy. However, years prior, there was a man by the name of David Letterman. He invited Lee Merrick and his science kids, kind of suspect if you ask me, to come from the Diet Coke and Mentos drink. And the rest is history. All right.
Yes.
You said it was because of the bumpy on the Mentos. Why does it not work with the other candies?
Well, it's got to do also with the breakdown of it. It actually will work with some other uses, like different things you're putting into it. Because think of if you shake up the soda, it still explodes, not as spectacularly, but it's all due to the increase in nucleation sites. Actually, for Mentos, if you use the smoother Mentos, like there's some kind that's like super shiny, that's because they filled those little holes in the process of making them, and they don't work very well. Mentos have these microscopic, and there's just a ton of little ridges and holes that we can't see when we have Mentos in our hands.
Alright, again.
Everybody wants to bust out their electronic mobile devices. Yes, good. Science kids.
Eric,
There we go. That's awesome.
are we all in all good?
Alright, we're waiting on like two more. You don't want to play this.
Alright, we all in all good?
Yeah.
Alright.
Are you ready? More questions? Dang it.
Are you science kids?
Oh, Grace.
Let's get spec.
Good job, guys. All right, now we got a demonstration, so.
Everyone put on a coat and follow us outside.
Freezes in the air.
Keep in mind, we are not near anywhere the dean can see.
You said where should we be?
Go back behind the annex, maybe, by those dumpsters behind the annex.
Is that still recording?
Yeah, it's the timer.
Gotcha. Yep, all right. Now, if you follow us this way.
Well, it's the timer.
He was like, okay.
We wave to the camera. Some vlog.
Say hi, everyone. Thank you.
What is the? Is that the name? That's what I thought was funny about it.
Alright, we're gonna go over here by the dumpster, so when it explodes, we don't make too much of a mess.
So just get the dumpster sticky and the custodians and.
Exactly. Good news is it's gonna like snow and cover up the whole mess.
Yeah, and being an asks, I had no part in this. I value my job. I knew nothing.
It's not like you're filming it or anything.
Nah, you didn't need to know that.
Well, it's been a very fun day so far.
Further away, guys. Further away from where the children are. Come on.
What's our time, by the way?
You're at 14 right now.
Oh, okay, all right.
There's good, guys. Right there. But get in the grass. In the grass. Not where people walk.
Let's go.
You guys should see run down that hill.
It's a contest to get all of them in before it explodes.
I'm stressed. Wait, I'm not ready. If this gets on me, I'm gonna.
Alright, ready?
No.
No?
Okay. Are we doing this one at a time or what? You should have played this one.
Actually, we're gonna see who can get all of them in at once. Ready?
Finale.
3, 2, 1, let's go.
All right, well, I'll see if anything happens.
Keep going.
Party rolling.
Oh, missed it.
Oh, come on.
That's all she wrote.
Yeah.
So that's it.
You can see the carbonation has all been released now. So
that's-
the Mentos have fallen down.
That all happens because of science.
Well, if you drop a couple more in, you can see that it still kind of goes.
Because of science, oddly enough.
See, it's still kind of going, but that initial one's gonna be their best one.
Yeah, actually.
Well done.
All right.
Now go get warm.
Awesome job, guys. Please throw your stuff away.
Yeah.